Hey students, this is lesson 10.4, solving radical equations. We're going to learn how to solve equations containing radicals and how to identify extraneous solutions. So we're going to draw a line from each of these. Go ahead and pause here if you want and check back with your answers. Here's a new word for you. Extraneous definition means not essential or relevant. So in math, we're going to use that definition. Something that's extraneous is not relevant. Okay. Sometimes when you're solving a radical equation, you can end up with solutions that don't work because you're changing the equation. And here's an example. So if you solve negative square root of x equals x, and I'll just show the work there. Let's square both sides. If we square the negative square root of x, we get x. And if we square x squared, we get that. And if I subtract x from both sides, I get this. And when I solve that, I get 0 and 1. But when I put 0 into the original equation, it works. When I put 1 into the original equation, it doesn't work. So 1 is an extraneous solution. Because it doesn't fit the original equation. All right. So one way we can solve radical equations is to isolate the radical, and then we're going to use the idea that if you have any square root like this, a principal square root, and you square it, you get the radicand. So let's start by subtracting 11 from both sides. Then we get the square root of x is equal to 10. Then we're going to square both sides. And we get x is equal to 100. And then we're just going to check that and see if it works. So in our original equation, we have the square root of x plus 11 equals 21. Square root of 100 is 10 plus 11 equals 21. That's true. So we're good. All right, I'll let you try that one. All right, some physics equations use square roots in them. Here's an example of one. The velocity of a projectile is determined by the function v for velocity is equal to the square root of s over 3/100, where s is the horizontal distance in meters traveled by the projectile. If the velocity of a projectile is measured at 150 meters per second, what is the distance? So this is the velocity. So to figure out the distance, that's s. S is the horizontal distance, so we're going to substitute 150 for v and then solve it. And to do that, I'm going to square both sides, and that's equal to 22,500. And over here we get just s divided by 3/100. And then I'm going to multiply both sides by 0.03. 22,500 times 0.03 is 675. And then I can just check it, just make sure that 675 divided by 0.073, and then the square root of that equals 150. I think it does. So my answer is 675 meters. Horizontal distance. All right, here's another equation you can try. All right, solving with radical expressions on both sides. Again, we're going to just use the idea that if we square a square root, we're going to get the radicand of that square root. So So what we want to do is just square both sides here. When we do that, we get 3m minus 6 equals m plus 23, and then just continue to solve it. 2m minus 6 equals 23. 2m equals 29. M is 14.5. And then we just want to check our answer. 14.5, see if it works. And so we're going to do the square root of 3 times 14.5 minus 6, see if that's equal to the square root of 14.5 plus 23. And when we do that, we get square root of 37.5 is equal to the square root of 37.5. And that's true, so that solution works. All right, you try it. All right, when you solve an equation by squaring each side, you write a new equation. The new equation may have solutions that do not make the original equation true. Here's an example. If we have x equals 3, if we square each side, we get x squared equals 3 squared, which means x squared equals 9. And the solution to that new equation is 3 and negative 3. So we introduced a new solution that wasn't part of the original. So when we're squaring, we have to be careful. So if we want to solve this, let's say we want to square both sides to get rid of the square root. So we get this. Now we have a quadratic equation. I'm going to add x to both sides and subtract 6 to put it in standard form. That's factorable, so I'm going to write x plus 3 times quantity x minus 2 is equal to 0. And so x is equal to negative 3 and x is equal to 2. Now I'm going to check these solutions. Let's check x equals negative 3 over here in our original equation. So we get negative 3 equals the square root of the opposite of negative 3, which is 3, plus 6. And that is saying that negative 3 is equal to the square root of 9. But the square root of 9 is positive 3. So we get something not equal. That means this is an extraneous solution. That one doesn't work. Let's check our other one. If x is 2, we get 2 is equal to the square root of negative 2 plus 6. And negative 2 plus 6 is 4. And that checks out. So that one's good. So our only solution is x equals 2. We're going to cross out that other one. All right, you can go ahead and try that here. All right, which is the solution to 4, square root of 4r plus 7 minus 3? Isolate the square root here so we can do the squaring. So subtract 7, and we get the square root of 4r is equal to negative 4. Now we're going to square both sides. And that gives us 4r is equal to 16. Divide both sides by 4, and we get r is equal to 4. Then we're going to check that, make sure it works. So we're going to do square root of 4 times 4 plus 7 equals 3, hopefully. And that's the square root of 16. And that's 4. And that's 11, which is not equal to 3, so it's not a solution. Now, what that means is, since the solution that we found does not work, there's actually no solution to this equation. And if I go back a step here, just think about right here, this step. If I do the square root of 4r plus 7 equals 3, when I subtracted 7 from both sides, I ended up with this. And right there, you might know there's no solution because this means the positive square root of 4r and it equals a negative number, which is impossible. So you could stop there and say, no, that's not going to work. All right, I'll let you try it. All right, lesson check here, which is an extraneous solution of s equals square root of the quantity s plus 2. So let's first solve that. I'm going to write it down by squaring both sides. So we're going to have s squared is equal to s plus 2. And then we get s squared minus s minus 2 equals 0 by putting it in standard form. And that's factorable. We get s minus 2 times quantity s plus 1 is equal to 0. So s is equal to 2 and s is equal to negative 1. So the two possible solutions are 2 and negative 1. So let's check 2 in the original equation. So then we get 2 equals the square root of 2 plus 2. So 2 is equal to the square root of 4, and that's true. And then let's check the other one. We get negative 1 is equal to the square root of negative 1 plus 2. So negative 1 is equal to the square root of 1. And the square root of 1 is 1. So that one is not true. The extraneous solution is negative 1. The correct answer is C. All right, that's it. I'll see you tomorrow.